Hello and welcome to our lesson on graphs of equations. This is going to be from section 2.1 in our text. In this lesson, we're going to look at graphing several different types of equations. Our first example is going to be number 33. This is going to be an example of graphing a linear equation. Now, if you want to know how to identify an equation as linear, all you need to do is look at the exponents of the variables. So since x and y both have exponents of 1, that means that this is going to be a linear graph. The technique that we're going to use for every graph in this lesson is the same. It's a 4-step process. Step number 1, we need to isolate the y. So we're going to start by moving the x over, which will make it negative x. That'll give us 2y equals, now I'm going to switch these around. That'll say negative x plus 8. And then to isolate the y, I need to divide everybody by 2. And I'm going to do everybody separately. You'll see why in a second. The coefficient of x is understood to be 1, so 1 over 2 is a half. So now that's going to be negative 1/2 x plus 4. This is where we're going to stop because now we have y by itself. And I do want you to notice that since this is linear, this is in y equals mx plus b form if you've ever seen that before. But we're not going to use slope-intercept form to graph this. We're using a particular 4-step method that's a general technique that'll work for pretty much any type of equation here in this lesson. So, the first step is to isolate y. The second step is to create a table of values. And since y is by itself, we're going to pick values for x. And it shouldn't make much difference what you pick. 0 and 1 are usually good choices, but you can pick pretty much whatever you want. Now, since this particular problem has a coefficient of negative half, that means if I pick numbers that are even, I'm going to get nice whole number values for y. So I'm going to start with 0. 0 is usually a good choice pretty much any time. And that's because when I plug in a 0, the x term goes away. 0 times anything is 0. 0 plus 4 is 4. And that gets our first point. Now, if you know anything about graphing a line, you know that you only need 2 points. It only takes 2 points to graph a line. So I only need 1 more point, and I'm going to go with 4. Now, like I said, you can pick any number you want for x. I'm going to choose an even number, and I just randomly chose 4. And let's look at a little more detail how we get the y this time, okay? So in order to get the y value, I'm going to plug in my 4 for x, and that's going to give me negative 1/2 times 4 plus 4. And then I do order of operations. Multiplication first. Half of 4 is 2. Negative times a positive makes it a negative 2. And then I can do addition. Negative 2 plus 4 is 2. And that's the work that you would do either manually or electronically. You can feed this all into the calculator to get your y value. Now, I could do more x's to generate more ordered pairs, but since this is linear, I only need 2 points, okay? So remember I said this is a 4-step process. First step is isolate the y. Second step is to create a table of values. Third step, plot the points. So we're now going to go to the coordinate system, the XY coordinate system, and we're going to plot those points. 1, 2, 3, 4, 0 and 4. And just so you know, that particular point is the y-intercept because the x-coordinate is 0. The other ordered pair says I'm going to go over 4, and I'll be up at 2. Fourth step, okay? Connect the dots. So if you need me to run through those 4 steps again, those 4 steps are: isolate the y, create a table of values, plot the points, and connect the dots. And that's how we're going to graph pretty much every example in this lesson. And it'll work for most every equation. And that's going to do it for number 33. Next, number 46. This equation is definitely not linear because we do have a power greater than 1. And since the y has a 1 for a power, and the x, the biggest exponent that the x has is 2, that makes this particular equation quadratic. And if you know anything about a quadratic equation, every quadratic makes a parabola. It's either going to be an upward-facing parabola or a down-facing parabola. But if you have a quadratic, and again, we know this is quadratic because the biggest power is squared, is a 2, we're going to expect a U, a parabola. So step number 1, isolate the y. That step is done. Y is all by itself. Step number 2, we need to create a table of values. Now, again, I said you can pick pretty much anything you want for x, and 0 is usually a good choice, okay? I like to work with 0 because it makes things go away. If I plug in a 0, that's going to give me 0 squared minus 3 times 0, which is 0 minus 0, which is 0. And so that means that this particular parabola is going to go through the origin. And then I need to pick other numbers for x. So next, let's try positive 1. 1 is usually easy to work with. That's going to give me 1 squared minus 3 times 1, which is 1 minus 3, which is negative 2. And I need another point. If you're going to pick 0, which is a neutral, and 1, which is a positive, you also need to pick a negative. So don't discriminate against the negative numbers. They're numbers too. Now, negative 1 squared minus 3 times negative 1. Negative 1 squared is positive 1. Negative times a negative makes a positive 3. 3 plus 1 is 4. And what I'm going to do is I'm not going to just continue to randomly generate ordered pairs. What I want to do is do about 3 points and then go to the coordinate system and see how much of the parabola I can see. So we're going through the origin, 0, 0, the origin. If I go over to 1, I'm down at negative 2. And if I go to negative 1, I'm up at 4. Now, do you see what I can see here is I can see that this looks like the left-hand side of the parabola. And so that tells me in order to see the rest of the parabola, I probably need to pick a few more positive x values. And don't go crazy, okay? Don't pick like 5 or 6 of them. Just maybe do them one at a time. Like positive 2 would be a good choice. And let's plug in and see what we get. 2 squared minus 3 times 2. 2 squared is 4. 3 times 2 is 6. 4 minus 6 is negative 2. Oh, and do you see what I was talking about right here? Now I see y values that repeat. And so that means at positive 2, I'm going to be on the upside of the parabola. So this parabola is going to come down, turn around, and start going up. Okay, so it should start going up from here. I'll do one more value to prove it. Let's do one more over, positive 3. 3 squared minus 3 times 3. 3 squared is 9. 3 times 3 is 9. 9 minus 9 is 0. And again, I've got y's that repeat. And if you want to know the fancy math word for that, that's called symmetry. I'm seeing some symmetry going on here. And so here I can see this part of the U. Now, what I don't see is something called the vertex. The vertex is the center of the parabola. In this case, it's going to be the lowest point. And the vertex always occurs right in the middle of symmetric points. So if you consider these 2 points here, these would be points of symmetry because they're at the same height. And so if I go right to the middle of those 2 points, that would be where the vertex is. And so I am going to go ahead and prove that right in the middle between those 2 points is going to be an x coordinate of 1.5. And I'm going to call that 1.5. 1.5 is 1.5. And if I plug that in to the function, I should get a number lower than negative 2 because the vertex should go a little bit lower than these points right here. All right, here we go. 1.5 squared minus 3 times 1.5. And if you're thinking, I don't really want to do that by hand, don't do it. Use the calculator for that, okay? Nothing wrong with using the calculator to do the arithmetic. 1.5 squared minus 3 times 1.5. And my calculator, remember, defaults to a fraction. I would really rather plot the decimal, so I'm going to hit the SD button. Negative 2.25. Negative 2.25. And notice that that is a little bit lower than negative 2. And since that's the vertex, it should be just a little bit lower because it's got to be the lowest point on the parabola, the vertex. Now, I did a lot of detail on this, okay? Because I wanted all of the critical points. I needed points of symmetry. I did want to see that vertex point, the lowest point. That's kind of important. And this is the work you're going to have to show if it says show your work on a test. And I did follow the same 4 steps, okay? Isolate the y, create a table of values, plot each point, and then play connect the dots. And that's going to do it for number 46. And before I move on to the next problem, I do want to give you a little bit extra, okay? Because I feel like if I don't show you this extra thing, I'm going to be cheating you out of some learning. So I would like to introduce you to Desmos. Desmos is a website, DESMOS, desmos.com. It is an online graphing calculator that you can use during your homework if you want to verify your work is correct. And so what I'm going to do is I'm going to show you how to check electronically what we did manually. So we're going to type in our equation right here, y equals. Now, if you need to, you can pull up this little keyboard. It'll have an x, it'll have a squared. We needed an x squared, and a minus 3 and an x. And then you can minimize that if you want to. And the cool thing about Desmos is as you type the equation, it's going to interactively give you the graph. And what's better about Desmos than like a TI-83 or an 84 is you can click on this graph and you can move it around as you need it. And you can also scroll the mouse wheel to zoom in and out. So you can move the graph around and you can scroll in and out. Really nice. Now what I want to do is I want to scroll in on this vertex and see if it's where I thought it was. Another cool thing about Desmos is if I click there, it will show me the vertex as well as the x-intercepts and the y-intercept. So again, Desmos is a very nice tool, not to do the work for you, but to check your work to make sure you're correct. And this graph here that Desmos shows verifies all of the stuff I did by hand. Super nice. Next example we're going to look at is number 49. This equation is an absolute value equation. And so the shape of an absolute value is always a V. Just remember that V is for value, okay? Absolute value makes a V, and sometimes that V can be upside down, but the main thing to remember is that an absolute value graph makes a V. And so that means that this graph is also going to have symmetry, like the parabola. So, four-step process, I need to isolate the y, that's done. I need to create a table of values. And what I'm going to do is I'm going to teach you a little technique to help minimize the work here. If you pick a value for x that makes the absolute value part 0, that will give you the vertex. That'll give you the point of the V. So my question is, what number would I plug in for x to make all of this stuff 0? Well, that would be 2. 2 minus 2 is 0, and the absolute value of 0, LOL, is 0. Now that's going to be the vertex or the point of the V. And so then what I want to do is I want to pick an x value on either side of 2. And however far you go below 2, you need to go the same distance above 2 so that you can see that symmetry. So what I'm going to do is I'm going to go, just for fun, I'm going to go 2 units below 2. Okay, think about on the number line, what number would be 2 units below 2? Well, that would be 0. And then I'm going to go the same distance above 2 for my other x value. And that would be 4. And so these points should work out pretty nicely when I plug them into the function. Here we go. Plugging in for x. Absolute value of 0 minus 2. 0 minus 2 is negative 2, but the absolute value of negative 2 is 2. And then plugging in 4 for x. 4 minus 2 is 2. Hey, guess what? The absolute value of positive and negative 2 are the same, because absolute value is always positive. So that gives me a 2. Hey, look at this. Do you see the symmetry? I've got the same y coordinates for those ordered pairs. Okay, and that makes me feel good. So then I'm going to go to the graph, because if I use this technique, the technique that I just explained about finding the vertex first and then going equidistant below and above, you only need 3 points, because you know it has to make a V. So let's plot the points. 0 is up at 2. If I go over to 2, I'm going to be on the x-axis. That point right there, that's an x-intercept. And then if I go over to 4, I'm going to be up at 2. Isolate the y, create your table of values, plot every point, and connect the dots. 4-step process works, like I said, pretty much every time. And how did I know it makes a V? Because its absolute value makes a V. Now, again, that's it for this problem. That's done. But again, I want to show you Desmos one more time because it's freaking awesome. I can type in that equation, y equals, remember the keyboard here. Look at that. It's going to have an absolute value function. And that function was absolute value of x minus 2. And you can do that from the keyboard, or you can input it with this keyboard down here. Enter. And again, remember, I can minimize this. I can click and drag this around. I can see the vertex is at 2, 0. Hey, I can even see the y-intercept if I need it. Did I do that point? I did, didn't I? Look at that. 0 and 2. Verified. So there's Desmos showing me again what I did by hand is correct. And I really hope that helps you. Again, showing you how Desmos can help you out. For our last example here, number 52, notice that this equation has an x to the third power. This time our x is cubed. And what I'd like you to know is that anytime you have an x cubed, this is called a cubic equation, you're going to get what I call a squiggle. I'm not sure what the technical name is for that, but I call it a squiggle because it goes down. It's going to have a little part here where it squiggles, and then it's going to go up. Or it can squiggle coming down and then down. So an x to the third is always going to produce one of these shapes. And depending on how many other terms there are, it could do some cool stuff, like some really cool stuff here in the middle. The only way to know for sure how awesome it looks is to do points. You're just going to have to do several points to get the detail. Here we go. First step, we're going to isolate the y. Y is already by itself. Second step, we're going to create a table of values. And this one doesn't have a nice technique like the absolute value. It's more like the quadratic, where you're just going to start with some x's until we see the squiggle. So I'm going to start with 0. 0 cubed minus 2. Well, 0 to any power is 0. 0 minus 2 is minus 2. And that gives us a point to start with. And then it's pretty much up to you. You can pick whatever you want. Probably a positive number and a negative number would be a good choice. Let's say 1 and -1. You don't have to get extravagant. Just maybe stay close to home. 1 cubed minus 2. 1 to the third is 1. 1 minus 2 is -1. And then -1 to the third minus 2. Notice that when I evaluate negative numbers, notice I use the parentheses there. That is important. Please make sure that you're putting parentheses around your negative numbers when you evaluate them. -1 to the third is going to stay -1. -1 minus 2 is -3. And so what I'm going to do, a lot like I did on the quadratic, I'm going to stop at 3 points. I'm going to plot those points and see how much of the squiggle I can see. 0, -2. 1 is at -1. And -1 is at -3. And so just by looking at those three, only those three, you might think, well, that's just going to be a straight line. But we know, since it has an x cubed, that it can't be linear. So it can't be a straight line. So we're going to need to do at least a couple more points. What I think is going to happen is I think it's going to start to squiggle like that. That's what I think. So to figure that out, we're gonna do one more x here and one more x here. We're going to do a +2 and a -2 and see what happens. Are you starting to see that graphing using a table is a lot like trial and error? You do a few points, you see where you're at, If you need more detail, you add a few more points. And looking at the 3 that I've done already indicates where I need to look for these other 2 points. It gives me an idea of what other x's to use. All right, so here we go. 2 cubed minus 2. 2 cubed is 8. 8 minus 2 is 6. And then we're going to do negative 2 cubed. Remember, negative numbers need to go in parentheses, especially if you're inputting this in the calculator. Okay, let me show. Parentheses, negative 2. Now I've got a squared. Do I have a cube? Oh, I do have a cubed. It's in yellow. But if you want to do any power, that's going to be this button, x to the square, and it lets me input the power. So there's 2 to the third. I need to move over, minus 2. So I can input this in the calculator and work it out if I want to, or I can do it manually. Negative 2 times negative 2 times negative 2 is negative 8. Negative 8 minus 2 is negative 10. Either way, I'm going to get negative 10 out of that. And then let's plot those points and see what we've got. 1, 2, 3, 4, 5, 6. If I go over to 2, I'm up at 6. Uh-oh, I'm going to have to extend my line down here some. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At negative 2, I'm at negative 10. And do you see my intuition was correct? This graph is starting to curve down and up. And there's the squiggle. If you see right in here, there's the squiggle part. And that graph is done. And guess what I'm going to do? One more time, we're going to go to Desmos and check. So that graph was y equals, using my keyboard, I'm going to say x cubed. Now notice I don't have a cubed, but I do have this button right here that'll do any power. So if I click that, it jumps me up to the exponent and I can input a 3. But then I'm going to have to move down, and to move down, I can either click out to the side or I can hit the tab button. I think tab. Yeah, tab moves me down. Or just clicking out to the side moves me down. Minus 2. And then if I click and drag that up some, we're going to verify some of these points we just did. Okay, so there's 0, negative 2, which verifies this point right here, 0, negative 2. And notice that's the center of the squiggle. That 0, negative 2 is the center of the squiggle. And then if I go over to 1, let's see, can I do that? There we go. It's hard, but I can click on the graph and verify 1, negative 1. And I think I can also verify 2, but it's way up here. Look at that. There we go. 2 is at 6. And then if I move down some, way down at negative 10. There it is. Whoops. It's a little bit touchy. Negative 2 is at negative 10. So again, all of this work can be verified from Desmos. And the main reason I'm showing you Desmos is not to give you a shortcut for getting through your homework. It's to give you another tool to verify what you're doing manually, okay? It's kind of like a safety net, or like having a tutor there to check and say, yeah, what you did is right. And so that's going to do it for this particular lesson. If you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.